And number 5 is also a bit tricky. Okay, so the graph shows a partially of a dy dx. Okay, the graph is a straight line that passes through 1, 3, and 5, negative 1. Okay, without finding the equation, sketch the d2y dx square. So because this guy is my dy dx, I want to go down to d2y dx square, means I must think of him as my y. Okay, and then I must think of him as my dy dx. Okay, then you realize, hey, this guy is a straight line. Okay, straight line have a constant what? So we can write down straight line have the constant what? And y'all know the answer, but y'all just don't know how to say it. Y'all just don't know or that never come to your mind. Straight line have a constant what? Gradient. And this is the most important concept that you have to know / apply. They have a constant gradient. That means regardless of where you are on the straight line, if you are here, if you are here, you are here, doesn't matter. Your gradient is the same. And what is this gradient? So write down the gradient is equals to 3 minus 1 over 1 minus 5, and this will be negative 1. Okay, so it means that the gradient of him is equals to negative 1. So when I want to draw my dy dx graph, okay, how will it look like? It will just be negative 1 here, a straight line like this, 0, and then this guy is d2y dx square. Okay, it will just be a constant line at negative 1 because this line has a constant gradient. Alright, so next one, the stationary point occurs when x is equals to a. Stationary point, again, dy dx, so that's for, so this part is for a. B. Okay, dy dx equals to 0. Alright, but first, how you find your dy dx equals to 0? So paradigm shift a bit. That means this guy is a straight line. A straight line has an equation of y equals to mx plus c. Yes, but this one you don't have to write lah. Okay, but this guy is not y. This guy is dy dx. So dy dx equals to gradient is negative 1 x plus c. Like I shared with you all, I prefer to use this traditional method of using y equals mx plus c to find the equation online. Of course, you can also use your other method where it's a y minus y1 over x minus x1 equals to gradient. But because of this dy, because this y-axis is dy dx, so I think it's better to use this way. Okay. I change the y to dy dx because my y-axis is the dy dx. Alright, then I sub in a value that it passes through. Which value can I sub? 1, 3 or 5, negative 1? Yes, it doesn't matter because the line passes through both of them. Okay, but which is the better choice? 1, 3 or 5, negative 1? 1, 3, because like I will share with you all, it's positive. It's better to work with positive values. So this 3 is not a y. This 3 is the dy, is a dy dx because the y-axis is a dy dx. So 3 is equals to negative 1, 1 plus c, which makes c equals to 4. Okay? Okay? So that's why you will get the equation dy dx equals to negative x plus 4. Alright? So to find the stationary point when dy dx equals to 0, negative x plus 4 equals to 0, x equals to 4. Okay, understand? So in fact, this part, is it related to differentiation? No, it's not related to differentiation. It is what? Coordinate geometry. And again, you need to paradigm shift yourself because this guy, the guy that is on the y-axis is not y. It is dy dx. Okay, x equals to 4, so that, which means that a is equals to 4. Okay, so for the C part, if I want to draw the y against x, yeah, so 0, x, y. All right. A equals to 4 means we know that there's a turning point at x equals to 4. Okay. So what kind of turning point is it? So let's convert this all our information into a first derivative table. Four minus 4 plus x dy dx. Okay, and then the tangent. Okay, 0 flat. Okay, and 4 minus dy dx positive or negative? So wait, so this is the part where it's 4. So you must know how does the information fall into place. 4 minus your dy dx is positive or negative? It's positive because this is the dy dx graph. We are only concerned with the value of the dy dx. So on the left, this is your dy dx, so the dy dx is positive. Then tell me on the right is positive or negative? Negative, because it is at the lower region. Positive, negative. Up, flat, down. What kind of point? Maximum point. Okay, so now this question can be a simple question, it can be a hard question. So that means if they never tell you to label the axis, all right, all you need to do is to just, you know, draw this, maybe big, yeah, then this one go down. The turning point is there, then that's it. Okay, if the question asks you to find the equation, okay, which means I have dy dx equals to negative x plus 4, yeah? Okay, so we have here, we have our dy dx equation, negative x plus 4, which is here. Okay, some of you have learned integration, some of you haven't learned integration, but yeah, I actually gave the thing already. Okay, what you all learned in differentiation is, you have y equals to something, you differentiate, you get dy dx. Yes? Question, differentiate what? I get 4. So you see 4x is here. Okay? Differentiate what? I will get negative x. So there's a negative here, right? So the power must be a bit higher, right? So the power is x squared. But if you ask yourself, when you differentiate x squared, what do you get? 2x, right? But it's supposed to be x. So over here, put the over 2. Okay? Then actually you all learn integration already now. Alright? All you need to do is to understand how to get this from differentiation. Then you all know how to get integration already. Okay? But there's actually this thing called a plus c behind. Okay? Why is there a plus c? Because when you differentiate any constant, there might be a possibility of having a 1 behind, 2 behind, 3 behind, 4 behind, 5 behind, or 6 behind, or whatever number is behind. Because when you differentiate anything, over here will become 0. So there's always a plus c behind. Okay, so some of you, I'm going to teach you integration today. Okay, always remember to add the plus c behind, because there's a possibility when you differentiate the c, you get a 0. Okay, but the takeaway of this is understand how to change your dy dx graph into your y equals to fx graph, or use the information that you have from the dy dx graph to solve the question.